Hello, everyone. Real-time systems architect. We totally made that up, but it's pretty much what I do. I work with our real-time systems and all the way from our automation teams that are connecting, equipment to the field or field equipment to devices, collecting data into our SCADA system, pushing that into data historian, doing analytics on top of that, and then creating events, detecting events, and pushing them back out to users so they can know about them and do things with them. So we'll talk about kind of that whole kind of process, that loop today. Devon Energy is an upstream oil and gas company based in Oklahoma City. For those that aren't familiar with oil and gas, that means we get the oil and gas out of the ground. We're based in Oklahoma City. We operate mostly in the central US, so kind of from South Texas all the way up to Northern Rockies area, right there kind of just in the middle of the country. I think you'll find through this presentation, you'll see that we lean pretty heavily forward into technology and try to be a fairly innovative company when it comes to technology. It's just a timeline of kind of our past history here. One thing I do want to point out, and I've heard a lot of people talk about it this week, on the far left here, you'll see in 2011, we started investing in data governance and data management. And it sort of goes without saying, but it's easy to skip over this fact, but if you don't do this step, you can't do any of the other things that I'll talk about today. And if you have started a governance or a data management project and it doesn't feel like it's paying off, give it time. It takes a long time for it to really work. And I would even say we started this over a decade ago, and probably only in the last, I'd say 4 or 5 years, we've really started to see the fruits of that. And so it does take time, and just keep at it. As we go to the far right here, you'll see in 2023, as Gen AI came out, we started working with it pretty much immediately. We have deployed a ChatGPT-based digital assistant in our enterprise environment. It's a private instance, so we're not sharing data with all of you. It allows our users to interact not only with a chatbot or a GPT-based assistant, but it also allows them to access data that's in our internal Devon system that we've connected to it, and they can ask questions and get help and all those kinds of things. I found it to be great at writing code, SQL statements, things like that. It does a great job. It's once you learn how to use it to be effective, it can really help increase your productivity. In 2024, so last year, what I mostly focused on last year was what I called unifying our real-time data system with our other enterprise data. And so I'll talk a little bit about that today. We are an Aviva customer. We use the Aviva Pi system pretty heavily. Pretty much every part of Pi we configure, use, and do things with. Maybe things it wasn't designed for even in some cases. And on the right here, you'll see a bunch of different applications that we want to integrate all of our data from our real-time system into that we deliver to users. And so those are the things that users are touching, and we'll talk about why some of those are maybe important in our ecosystem here in a second. Our system is pretty big. We've got about 11 million tags in our Pi system, 100,000 assets. We're running a little under 2 million analytics inside of that system. We've created over 10 million events since we sort of started doing all this event detection that we'll talk about. And we're sending a little over 2,000 notifications per day through that system. And those aren't notifications that you would think of like an email or a text message. Those are really webhooks or REST calls into other systems to deliver data to other applications so that our users can get insights delivered to the tools that they use on a day-by-day basis. We are a very data-driven operation. But out of those 11 million tags, one thing that surprised us when we kind of did this, started looking at this, only 30% of those are actually from our SCADA system from the field. Another 40% of those tags are actually things that we've created as outputs in our analysis system in Pi or in some external system where we're doing data science modeling or some other advanced analytic. That surprised us. Engineering, we also try to be pretty data focused there as well. When you talk about engineering, they want to see different things. So here I've got a process. Oops, sorry. You started already, didn't you? Let's go back. Oh, can you start that for me? Thank you. So your field teams want to see something more like this, like a process display that they're going to operate off of. Our engineering teams typically want a PNID type of view, or maybe a process flow diagram like you see here. What we do with the IO view, which is a product we've started using for visualization, we fly our sites with a drone, and we take a bunch of pictures of them. And some of our data scientists were able to turn that into a 3D model that looks kind of like VR or AR. And so we're able to actually put data on top of that from inside of IOTA View. They're able to read the file that we create, and now we have a 3D model of our site. We don't have a lot of CAD drawings for engineering. We don't CAD or do drawings for every location that we build. And so this was a kind of a really interesting way to deliver a 3D model or a 3D environment to our users that we're pretty excited about. We don't know exactly where this is going to go, but I know facilities engineering is pretty excited of maybe some of the potential there. And we're still pretty early here, but excited to see where we can take it. Data quality is something else that I've heard a lot about since we've been here this week. I think we know that data quality is a problem, especially for time series data, and we don't know what to do about it. Like I said, we've got 11 million tags, so I can't, even if 10% of those are in error at any given time, I can't have a million data quality issues show up in a dashboard somewhere every day. That doesn't me no good. What do I do with that? So we've been working with Aperio to try to kind of get ahead of that and figure out how do we find out about these things that need to be fixed earlier and not have our users contacting us and saying, hey, it looks like this sensor flatlined, or we have a data point that's out of range that's messing up all of our maybe field roll-ups or whatever the case may be. And so Aperio is helping us do that. They do that through some raw math. They've got some ML type models also that run. They can do anomaly detection, lots of different things they can do on that data set. And so we're very hopeful that we can crack this problem with Aperio. The other thing I really like about it is this DQI score that you see here. It says 83%. It gives us a way to track in a metric-based way. We can set a baseline and say, like, the first time that we scan these, or we have an actual metric for what our data quality looks like. And then when we do projects that our goal is to improve data quality, we actually have a metric to track against to say, did that project improve our data quality like we thought it would, or are we spending money and not getting anything out of it? Okay, so what really is the problem with real-time data? It may be different in all of your organizations. For ours, what our users essentially tell us is it feels like our time series data is kind of locked up in a system that they don't know how to access. What they do know how to access is a SQL-like table or a SQL-like environment. We use Snowflake as our kind of primary unified data layer. And what they want is just to be able to do select and join type statements against time series data and connect it to accounting data or connect it to ERP data or what have you. That's what they want to do. In order to do that, data comes out of our Pi system. It's immediately available for process visualization, which that part's great, so operations is happy. We want to get it to Snowflake, so what do? We put an ETL tool in place, or an ETL process of some kind. This is probably what most people's process looks like to get any time series data to a data lake or to some kind of data fabric that's not your historian system. And so we have these kind of pile up on us over time. You get to where you have 100 of these, it gets to be kind of a maintenance support nightmare. And anytime you have a data outage or you have an event that occurs that requires maybe to go backfill some of those tables, you've got to spend time as a support team, go back to those jobs, you got to rerun them, backfill that data, clean up those destination tables, make them look better for the users when you had whatever event that occurred. And it's a real problem. So what we did, we've worked over the past couple of years with Radix on a tool called Leafcutter. That's an event-driven streaming data tool, and it essentially is syncing data from Pi onto a Kafka broker, onto a Kafka message topic that then we can consume in Snowflake via Snowpipe. And what this does is essentially make it so that when data is late arriving, when data needs to be updated or fixed in Pi, we can just fix it in Pi, and then Leafcutter takes care of identifying that that data changed and needs to be resent, and it just handles all of that for us. So we get the data to Snowflake. Our data scientists like it to be there because they want to pull massive amounts of data to do any kind of data study or data correlation or multivariate analysis or whatever the data science people do. I'm not a data scientist. They want to be able to do these big things. We also want to be able to report on that data. We want to infer some models maybe with that, with the goal being to create some events that go back into Pi. And then from there, we can use the notification system that I talked about earlier to tell somebody about it, typically another system. So this is just an example to show you that we can now query data out of Snowflake on tag-based data, on time series data, that just looks like SQL to a user, with the eventual goal being that we will be able to essentially replicate our PyAF structure, so all of our metadata and asset data that helps contextualize all of that real-time data, and make that available to Snowflake. And then our users will be able to ask for data in a more English-like way, as opposed to having to know the point name that, if you guys work in a SCADA system, you know that they get a little bit nasty sometimes. The other reason to do this is that pretty much all of the business tools that we use, they already know how to connect to SQL databases and put data in their system from SQL. And so this also enables us to put this real-time data in some of those applications if we want to, and to make some of that integration piece a little easier in the future. So how does this help data science? I talked about how they can run these big queries now. They can do multivariate analysis and things like that much simpler than they could before. They don't need to know how to talk to Pi. They don't need to know how to use a higher level language. They can just use Python and a SQL driver, pull data out of Snowflake, and they can go on their way. The other thing it enables us to do is to actually subscribe those data science models to updates. So as data is coming from Pi, we can subscribe those models to the Kafka data pipe and start executing or inferring models as data changes or as a certain set of conditions change, like a certain set of criteria is met, and allow us to do quicker inference. Now, there's a lot of things where you could argue, okay, well, a daily run of that's probably fine. A weekly run, maybe that's great. We do have a few cases where, especially in drilling completions, where we're operating on like a 1 second data speed, and we want to be able to give feedback to somebody much quicker, where we want to have data hit Pi, push it out onto Snowflake through Kafka, have it be available on Kafka very quickly with fairly low latency, execute a model, put results somewhere, and then be available to a user within, say, 2 to 5 seconds. What we've seen so far with this tool set is that we can deliver data to Kafka in about 2 seconds. 2 seconds or less is generally what we're seeing from the time the data hits Pi to the time it's available on Kafka. And that's fast. It's probably faster than we need today for most of our applications, like I say, but we hope that this enables us to do some more advanced things, or to maybe think about solving problems a different way in the future. And then, as I said, a lot of the other applications our business users are using are also querying data out of Snowflake, and this makes it so they've got access to it. Just a little bit about scale. I mentioned we have a big system. So obviously one of the things we're concerned about is, can we do this with even half of our tags? Now, not everything probably will go, not all of those 11 million tags maybe will be interesting enough to send into that data fabric layer. But so far, I've got 3 of my 7 kind of business areas that we support in this system We're about 2.5 million tags in the system right now. And we're running right around just under 500 million data record updates per day. So we're doing this at a pretty high scale so far. I expect this will double once we get everything in here, and we should be pushing close to 1 billion a day by the time we're done, I think. I hope to hit that number anyway. I want to put that on a chart. Okay, so how do we do data science at Devon? Typically, our data scientists are using Databricks. That's kind of their tool of choice, Python notebook style type thing. If an engineer is going to do the work, it's going to be done in Seek typically. The visual environment there works really well for an engineer to sit down and solve a problem and iterate over it very quickly. We take the results of these. Again, earlier I said what we want to do with all these tools is to detect an event occurring so that we can send that somewhere. We take those and we put that into an event-driven architecture that we call the real-time platform. It's something that we've custom developed internally. And those can be Pi event frames, Seek capsules, just an output, like a table output from Databricks. And we push that into the app that it needs to go to. So here's an example. We're pushing this into a data management platform that we've built. We call it DSC Portal. DSC is Decision Support Center. They're like our kind of local control centers out in the field that are kind of directing traffic, telling people where they need to work, helping to make sure the right people are going to the sites that need help at the right times. It'll show up in that tool on a line. We call these actionable insights. We're not marketing people, so we're not good at naming things. We just named it generic actual insights. It'll have details about the event, what system detected it, what is the event, any other pertinent information that we want to provide with that. And then it will kick it into a mobile app that we've also developed that will allow that user to take that work, go execute it, make notes on how they closed the work order out, and then any other documentation we might need, and then close that work order and move on to their next job. So it kind of gives us full loop from data from a piece of equipment all the way through SCADA into analytics and back around. And a lot of these analytics too, Colin had mentioned that Gen AI, not everything is a Gen AI problem. I would say probably 80% of these are just math. They're basic analytics. They're not doing anything super fancy. They might be, maybe multivariate or multiple process items, but they're not doing anything ridiculously crazy. We do have a few that are using what you would call traditional ML or AI models, or larger maybe statistics-based models. And then we also here recently, I'll talk about a few things where we're doing more with Gen AI as well. Which, speak of, one of the things I kind of wanted to highlight here was just one of the projects that we've done with Gen AI. When we build, I don't know, maybe a couple hundred new facilities, new sites a year. And when we go into the planning process to go do that, the engineering teams and the planners need to review a bunch of documentation, previous work orders, previous work site reports. That's mostly all free text that somebody is just typing a report out. And we've been able to utilize generative AI to review all of the maybe related sites that were built in that area and sort of help categorize, aggregate, and spit out kind of the general themes to that planning group. They've been able to reduce their planning time by about 90% using this kind of new process. We also do some image analytics. Now, most of the pictures I'm showing here are more traditional machine learning or what maybe AI, where they're doing image inference with a model. We think that we can improve upon this with a generative AI integration to add to that. But things like detect smoke on a flare stack, because if a flare is smoking, it's not burning efficiently and it needs to be addressed. Do we have tank vents that are open? We want those to be closed all the time. So we could potentially, we think we can use maybe Gen AI to see those kinds of things, based on camera placement and things. So if you think back to that timeline I showed earlier, if we look back in a year, 2025, what will it have on it? We want to continue to mature data quality for time series data. We want to start making the data science outputs not just an actionable insight that goes to a user, but to actually insert some of that into closed loop control systems, and to start trying to have a larger maybe impact on some of the things that we know that we can have a computer system or an advanced model help us optimize. Generative AI agents is something that I guess I'd say we're excited about. We know that we can build specific, like purpose-built agents to go and do certain things, and our development teams have already been meeting quite a bit to talk about how you do that, what's the process look like, and to use our platform to inject those into the system that the users are going to use. And it's amazing what you can get done with some of those. And then to better leverage some LLMs, and there's tons of them out there that are all, purpose built to do specific things. And we've got a team that's kind of exploring a bunch of those, and we're learning what can be done with some of those. So with that, I wanted to thank a couple of the vendors that helped, or partners really, that have helped us over the past year kind of get to where we are right now. And that's all I had. Thank you for your attendance.